Good afternoon, AP Calculus students, future and present. I am glad to have you here today. As today we're going to be learning about extrema min and max, where to find relative max and minimum, and seeing where the open intervals are when the function is increasing and decreasing. So let's start, shall we? So for the homework, you should have gotten, so for number one, it should be, so for number one, it's going to be y is equal to x cubed. Sorry for my bad handwriting. I might have to go a little bit slow. Square plus 7. Okay, so the first step, as we all know, is to do y prime of this equation. You bring down the 3, you subtract 1, 3x squared. Bring down the 2, you get minus x, and this is your derivative. Now we want to factor to try to find x values that could give us 0. So we're going to set this equal to 0. So the only way to factor this is if we have this equation right here. My bad. This is an 8 right here. So sorry for my handwriting. So we know that our critical points are at x equals 0. That's one of our x values. And right here, let me write this on the side for us. 3x minus 8 is equal to 0. You add 8 to both sides. You get 3x is equal to 8. You divide both sides by 3. And you get x is equal to 8 over 3, which is our other critical point. Now, we want to write the chart. So, the chart that we're going to write, as we all know, we're going to go down right here and right here. So, the first goes right here is interval. Then we have the number that we're going to plug in. And then we have the sign that we're going to get either positive or negative. Then we're going to put in our intervals. So, it's going to be negative infinity. 2, since 0 is smaller, it would reach 0 first, which is one interval. And then afterward, we will have from 0 to 8 over 3. And then we are going to have 8 over 3 to infinity. My infinity looks really bad. Just hang in there with me. So, a number between negative infinity and 0, negative 1. A number between 8 over 3 and 0, you could choose 1 or 2, doesn't matter, but to make it easier, we're just going to choose 1. And something over 8 over 3 to infinity, which is 3, because 9 over 3 is equal to 3, and 9 over 3 is past 8 over 3. So, for negative 1, remember this number right here, we're going to plug it into this equation. So, we plug in negative 1 into this equation right here. So let me bring it down really quick. So it was 3x squared minus 8x, if I remember correctly. Yes. We plug in negative 1, we get 3 times negative 1 squared minus 8 times negative 1. And we get 3, because that's going to turn into a positive 1. You multiply it, and that's going to turn into a positive 8, and that's going to give you 11, which is a positive number. Then we plug in 1 into the equation. We're going to get 3 times 1 squared minus 8 times 1. We know this is going to be 3 minus 8, which is going to give us negative 5. That is a negative number. Then we want to plug in 3. So when we plug in 3 into here, we are going to get 3 times 3 squared minus 8 times 3. And you're going to get 9 times 3, which is 27. Then 8 times 3 is 24. You are ended up with a 3, which is a positive. Now, we want to um, now write what we got as our answer. So now right here, if it's going from positive to negative, so it's going to be increasing, as we know, slope, and then it's going to decrease. From here, it's going to be going decreasing, and this. So these are the parabolas that you're going to get. Not a parabola, but these are the way the function is going to look, however the function looks on the graph. So at one point between these points, this is how it's going to look. So from here, we could write that the interval, we could write the increasing interval as, and you look at your positive signs, which is from negative infinity to 0, and from 8/3 to infinity. So we would write, it is from negative in, negative infinity to 0, union, that's a U. You do not want to draw a U. You want to draw just a U with no line. Anyways, either that or you could just do a comma. Doesn't matter. Um, don't do both, but that's just an example. 8/3, comma, infinity. My infinitors are looking bad, but hang in there with me. And our decreasing is from 0 to 8/3. And our relative max and min are at x values. So we see right here, let me get a different color so we could see this. Right here is a max. It is at the top. Right here is a minimum. So a max at this coordinate, which is 0 as we can see, is at a max. Right here, this coordinate is 8/3, as we can see, this side and this side. So at 8/3, it's at a min, and at 0, it's at a max. So right here, we would write relative max. Kind of struggling here. Max is at x is equal to, and what did we say? 0. And then relative min is at x equals 8/3. The homework does not state whether they want the points. It just wants the min and max, the relative. So, yeah, I would say find all absolute points. So we're just gonna write this since it's just asking for the relative min and max and for the intervals. So that's number 1. And because you might have gotten the gist of it, we are gonna go a little bit faster. So number 2, we have y is equal to 2x squared plus 16x plus 32. Alright, first step, find the derivative. Always, we have 4x plus 16, and we solve and we set it equal to 0. It's going to be 4x. 4x is equal to negative 16. Since you would subtract, you divide both sides and you get x is equal to negative 4. That is our critical number. It's our only critical number. So now we're just going to make a little chart as we always do. So this is our interval, this is our number, and this is our sign. Okay, now we're going to write negative infinity to negative 4. I know my handwriting is really bad. And then it is from negative 4 to, let me actually try. There we go. That's a bit better. Okay, so we want to find a number that we could put into negative infinity to negative 4, which would be, we could just do negative 5. It's the closest. The closest to this, doesn't matter if it's closest, an easier number would be 0. So when we plug in -5 to the derivative, we would get -20, because -5 times 4 is 20, as we know, but it would be negative, and then plus 16, which means we would end up with -4, which means it would be a negative. Plug in 0, and you get positive 16, which means it is a plus. That means the function at one point goes like this. It decreases, so that means our point of -4 is at a relative min. So now let's write the increasing and decreasing intervals. So it is increasing at -4 comma infinity, and it is decreasing at negative, actually, yeah, I just realized it's the other way around. I'm so sorry. Um, just delete this. Get a better. Here we go. Perfect. Okay. So as I was saying, this is our. Let me get back to drawing. This is our. Oh, there we go. This is our increasing. And this is our decrease, which would be from negative infinity. Okay, I really need to get better at that. To -4. Good, good. And we have our relative min at x is equal to -4. Next on to number 3. For number 3, we have y is equal to x squared over 2 plus x minus, that looks like a y. I said minus, not plus, minus 9 over 2. Okay, so a lot of people had trouble with this one, as they thought you had to do the quotient rule for the first one. However, you do not do that. You can rewrite this. This is not derivative. All you're doing is rewriting it. You could rewrite it as, and then x over times x squared. It's basically being multiplied. The 1 over 2 times x squared, but you don't need to write multiply or the dot or multiplication symbol to signify that they're being multiplied. Plus x minus 9 over 2. So now we find the derivative. So you get 2, and then it would be 2 over 2x. That cancels out, so you just have x, and then the derivative of x is just plus 1. So we are left with x plus 1. We set it equals 0. That looks at 6. And then we have x is equal to -1. Okay, so now we draw the chart. So we have interval, then we have number, then we have sign. As you can tell, I'm speeding up, but my handwriting is also getting a lot worse. Okay, so now from here, we are gonna go from negative and go from negative infinity to -1, and then we are gonna go to -1 to infinity. Wow, that one was way better. Okay, so a number we can plug in is -2. A number we can plug in is 0. So this is going to be, we plug in -2 into the derivative. That would give us a negative. And this one would give us a positive. So that means our graph is going to look like that, which means at -1, it is going to have a relative min right there. So, yeah. So our decreasing is going to be from negative infinity. Yeah, always got to make sure you're right. Decreasing is going to be at negative infinity to -1. Our increasing is going to be from -1 to infinity. and then our relative min is gonna be at x is equal to -1. Good. Let's move forward. Number 4. This seems kind of repetitive, but practice makes perfect. It's kind of cliche, kind of corny, but it's true. So, don't know why I made that comment. Anyways, we're gonna go to number 4, -2x squared minus 12x minus 18. So, we're gonna find the derivative. We know that's gonna be -4x minus 12. So we've set it equal to 0. That's gonna be -4x is equal to 12, and that's going to be x is equal to -3. So that is our critical number. So now we're going to make the charts here. So that's our interval, this is our number, and this is our sign. So let's make this a little bit longer. I know it's probably going to take up a little bit more space. So we're going to do negative infinity to -3. Sorry for my bad handwriting. And then we're gonna do -3 to infinity. And a number between this is -4, and a number between this, easy, 12. So now remember, always plug the number that you chose into the derivative, not the original equation. So if we plug it in, we're going to get +16 minus 12, which is going to give us a +4, so it's going to be positive. We plug in 0, and that's going to leave us with -12, so it's going to be negative. So it's going to go like this. So we have a max at -3. So at x equals -3, not at the y value of -3, at x value. So our increasing interval is going to be from -infinity to -3, and then our decreasing is going to be from -3 to infinity. And then our relative max will be at -3. At x is equal to -3. Moving on, number 5. Number 5, it's a terrible circle on number 5. For number 5, we have y is equal to x to the power 3 minus 4x squared plus 2. Okay, so now we find the derivative as always. It's gonna kind of get repetitive. We're gonna get 3x squared minus 8x. And you set this equal to 0, just as, like, what did we have this for? We had this as number 1. So you factor it. You're going to have 3x minus 8 is equal to 0. So that means your critical numbers are at x equals 0, and x is equal to 8 over 3. If you want to check that for yourself, go ahead. I insist. And we make our chart. Right here is our interval, right here is our number, right here is our sign. And if you feel confident to do this yourself, then go ahead, but there's nothing wrong with following this. So we're gonna plug in our -infinity to 0, and then we're gonna plug in our 0 to 8 over 3. Then we're gonna plug in our 8 over 3 to, and oh my god, it's so bad, infinity. Okay, now from here we choose a number, -1, then we could choose 1, and from here we could choose 3. So our sign, if we plug in -1 into the derivative, we are going to get -1, you are going to get a positive, and so that's going to be a positive. This is going to be a negative, and this will be a positive. If you want to double check that, go ahead. So our graphs are going to look like this, increasing, then decreases, and then decreases. So then we have a min at 8 over 3, and we have a max right there at 0. So we have increasing intervals from, we see where it's positive, and we have -infinity to 0, union 8 over 3 to infinity. Then we have decreasing from 0 to 8 over 3. And we have our relative max at x is equal to 0, and we have our relative min at x is equal to 8 over 3. That is for number 5. I'll start writing the answers in red so we could signify the difference. Be a lot easier for myself and people watching. 6. So now we have x to the power of 3 plus 8x squared plus 21x plus 18. So remember, first step, derivative, we have 3x squared plus 16x plus 21. Now, right here, this is a quadratic formula. You can go many different ways of this. You could use the quadratic, you could complete the square, you could use the quadratic formula, or you could just factor, which is what we're gonna do because those other ways are way too long. So this is gonna be plus 7, this is gonna be, I believe, plus 3. Let me see if I'm right. I am wrong. No one's perfect. So this is gonna be plus 7 plus 3. Yes, that is right. So we have x is equal to negative 3. And then x is equal to negative 7 over 3. So from here, for number 6, we are going to write down our charts. Just got to make it long because you never know. And then we are going to write our number and then our sign, then our intervals, which would be from negative infinity. In this scenario, negative 3 is less than negative 7 over 3. Negative 3, then interval negative 3 to negative 7 over 3. I believe this negative 7 over 3 would be 2.33, if I'm not mistaken, something like that, which is why it would be greater than negative 3. So don't forget to close the parenthesis. Then you have negative 7 over 3 to infinity. Now, we want to plug in a number, negative 4. You could do, so this one is a little bit tricky because it's more than 2, but it's not greater than negative 3. So we're going to have to plug in negative 8 over 3. From there, right, this one we could plug in 0. So negative 4 into the derivative. Always remember that. This might take a little bit longer. That's going to be 16, 48, 48 minus 64 plus 21. That's going to be 69. Yes, it's going to be 69, so it's going to be positive 5. We plug in 8 over 3. This is going to take a lot longer than I thought it would be. So we plug in negative 8 over 3 squared, which would be 64 over 9 times 3. And then we would have plus, and then 16 times 8, if I'm not mistaken. 10 times 8 is 80. 6 times 8 is 48. 80 plus 48 is 128. In this scenario, negative 128 over 3 plus 21. So then we would have 3 times 64, which is 180, and then 192 over 9. Then to simplify that, we want to make it the same denominator, least common denominator. So we're going to multiply that number by 3. Unless we could divide this number by 3. And fortunately we can. 192, if I'm not mistaken, since we multiplied it, it'd obviously be 64. So it would be 60. So this would turn into 64 over 9. plus 3 plus, it would be minus actually, minus 128 over 3, which we would get, that would be half. So it would be negative 64 over 3 plus, and then we do the least common denominator. 21 times 3 is 63 over 3, and that would give us a negative. Let me just make sure that is correct though. We always want to be sure of our answers. Let me grab my calculator. So we have 3 times negative 8 over 3 squared. And then what would be the next number? Then it would be plus 16 times negative 8 over 3 parenthesis, and then plus 21, in which we would get negative 1 over 3. So I was right in this scenario. Luckily, don't embarrass myself, to be negative. So that was right. Plug in 0 into the entire equation, we would get plus 21. So we would get plus. So then our thing's going to look like that, and then everything's going to look like that. So at negative 3, we have a max. At negative 7 over 3, we have a minimum. So now let's read its answers. As I said, I was going to rewrite this as in red so it can be more noticeable. So it's increasing from negative infinity to negative 3. Infinity to negative 3. And it is union from negative 7 over 3 to infinity. And then it is decreasing at negative 3 to negative 7 over 3. And then our relative, let me check if that's true. Yes. Then our relative min is at x is equal to negative 7 over 3. And our relative max is at x is equal to, what was the answer we got? Negative 3. Yes, that's correct. Okay, on to number 7. That took us a little bit longer than I wanted to, but that's fine. So to number 7, we are almost halfway there, basically halfway there. So number 7 would be y is equal to 2x squared plus 16x plus 34. So you would find the derivative first. Y is equal to 4x plus 16. You find what x is equal. That would be negative 4. Then we write the chart. Make it a little bit longer. We have interval. We have number. Then we have sign down here. So then it would be from negative infinity to negative 4. And then it would be from negative 4 to infinity. So find a number. It could be negative 5. This could be 0, negative 5. It almost seems really similar to, I would say, number 2. So then negative 5, you would obviously get a negative as your answer, and you would get a positive 16. It would look like this, so that means a minimum at negative 4. So that means that our relative min, is that x is equal to negative 4. We have increasing interval at negative 4 comma infinity, and we have decreasing at, we're decreasing at negative infinity to -4. Let's check our answer. 7, -4 to infinity, and negative infinity and -4, decreasing. That is exactly correct. Moving on, number 8. Number 8, which is y is equal to negative x squared over 2 plus 2x plus 2. So remember what we had the first time. If you missed out, go back to problem number 3. So we are going to have negative x plus 2, and we set it equal to 0, so then we would have x is equal to 2. So then that is our critical number. We make our charts a little bit longer. So this is our interval, this is our number, this is our sign. So then we would have negative infinity to 2, and then we have 2 to infinity. So then from there, we're going to pick a number. It could be 0, and this could be 3. We plug it into the derivative. This would be a plus, this would be a minus. So then it would go from growing, and that means it would be a max. So we have our relative max at x is equal to 2, and we are increasing on the interval from negative infinity to 2. And we are decreasing from 2 to infinity. Let's double check our answer. For number 8, increasing, negative, yep, and yes. Okay, so let's move on to number 9. We are almost done, just 6 more questions. Number 9, we have y is equal to x squared. Let me try to rewrite that because that looked very bad. So then we have x squared over 2 is like the other one, minus x minus 3 over 2 y prime, or the derivative would be 1 minus, sorry, it would not be 1, it would not be 1, it would be x minus 1. Set it equal to 0, x is equal to 1, that is a critical number. We make a chart. We have interval, we have number, and we have a sign. From here, we would go negative infinity to 1, and then we would have 1 to infinity. Terrible looking infinity. And then you could plug in 0, you could plug in 2. 0 would get you a negative, and the 2 would give you a positive, meaning that would be a graph. That means that would be your min. So you would have your relative min at x is equal to 1, increasing on the interval of 1 to infinity. And then you have your decreasing interval from negative infinity to 1. I know my handwriting is getting probably even worse, even though it should be getting better technically. But I promise I will practice. Number 10. Number 10, we are almost done. We did the 11, 12, 13, 14, and 15. So we have y is equal to negative x cubed plus 9x squared minus 24x plus 18. Okay, so now we find the derivative, and that would be negative 3x plus 18x minus 24. So now we can factor this. So we would have negative, I forgot to bring down the square. Don't forget that. I'm so sorry. Negative 3x. This one might be a little bit harder. Actually, I just realized something. We can divide everything by negative 3. So afterward, we would have x squared minus 6x plus 3 plus 8. I'm so sorry, my arithmetic is it's all over the place. So negative 3, yes, and yes. Okay. So after this, you factor, and you would have x, and there's only like possible solution. It doesn't matter where, but -4 and -2. So that means x is your critical numbers at x is equal to 4 and x is equal to 2. So now we draw our chart. Yeah, that doesn't look too good, but it's okay. So number and then sign. And then we have our first interval from -infinity to 2. And we have our other one to 2 to 4. And we have our other one at 4 to infinity. So we find a number. You can plug in 0, you can plug in 3, and you can plug in 5. You plug in 0, you would get a positive. You plug in 3, that would be 9 minus 18. 9 minus 18 would be -9. And then from there, you would have a positive 8. -9 plus 8 is a negative. You have a 5. 25 minus 30 is -5. -5 plus 8 is a positive. So this is going to look something like this and something like this. So we have a min at x is equal, x is equal to 4. And we have a max at x is equal to 2. So we scroll down just a tiny bit. Hopefully I can remember. I haven't even been checking the answers. Number 10. Yes, okay. Okay, so as I was saying, we have our relative max. Okay, this is looking even worse. At x is equal to 2, our relative min at x is equal to 4, and then we have our increasing from negative infinity to 2 union 4 to infinity, if I'm not mistaken. Yep, and our denominator to that decreasing would be from 2 to 4. Yep, almost done. Very close. 11. Now for 11 we have y is equal to negative x cubed plus 3x squared plus 2. We have negative 3x squared plus 6x. So as we see, we can only factor that out. So it'll be -3. Actually, no, let's just. I mean, it would be the same thing. Okay, so yeah, let's just leave it like that. So then plus 6 is equal to 0. Or you can divide everything by -3x. But x would be equal to 0, and x would be equal to 2 if I'm not mistaken. Yes, it would be 2. So those are critical numbers. So then we make our charts. So then we have our intervals, our number, and our sign. So we have negative infinity to 0, and then we have 0 to 2. That's odd looking. And we have 2 to infinity. So now we can plug in -1, we can plug in 1, and we can plug in 3. So -1 and 2, the derivative, which would be, I forgot to write the derivative, -3x. So you write that, and that would be -3, and then that would be negative. So then, would that be negative? Yes, it would. And then 1, so it would be 6 plus 6 minus 3, which would be positive. and I'm guessing 3, so 9. Negative 27 plus 18 is obviously a negative, so this would go from decreasing, increasing to decreasing. So this would be our max, this would be our min. So we have a min at 0 and a max at 2. So now we scroll down and we can write our relative max at x is equal to 2, our relative min at x is equal to 0. We have our increasing from 0 to 2 and our decreasing from negative infinity to 0 and union to comma infinity. Now we shall move on to 12. We're so close. 12, which would be y is equal to 2x squared plus 8x plus 2. Remember, you do not have to do all of this. This is just for reference if you get confused on one of them. So then y prime is 4x plus 8. So then our x would be equal to negative 2. So that's our critical number. So then afterward, we would write, let me just make sure, yes, it was. So we would go like this and like that. So we have our interval, our number, and our sign. And then we have it from negative infinity to negative 2. And then we have it from negative 2 to infinity. So then right here we could plug in negative 3, we could plug in 0. 0 would give us a positive, and then a negative 3 would give us a negative. So it would look something like that. Yes, so we have a relative min. We have a relative min at x is equal to negative 2, and we have an increasing interval from negative 2 to infinity. And we have a decreasing from negative infinity to negative 2. Now let's move on to 13. We are so close to finishing. Thank you if you've been watching this entire time. Y is equal x squared over 2 minus 1. Y prime is equal to negative x. That's it. And we set it equal to 0. X is equal to 0. So that's our critical number. So then it would be from negative. Oh wait, let's do the chart. I'm going a little bit too fast. Never want to do that in calculus. Interval number sign. Interval is from negative infinity to 0. If I'm not mistaken, for number 13. And then we would have 0 to infinity, which would be, so then we could plug in negative 1 and we could plug in 1 right here. So when we plug in negative 1 into the derivative, it would be a positive and this would be a negative. So that means so between these two, it would be going from positive, so it would go like this. So that's the relative max. So then we have a relative max at x is equal to 0, an increasing interval from negative infinity to 0. And then we have our decreasing from 0 to infinity. We are getting even closer, second to last problem, before we do another video on finding absolute minimum and maxima given on an interval of a function. So 14, we have y is equal to negative x squared over 2 minus 4x minus 6. Now we have y prime is equal to negative x, and then negative 4x, which would be negative 4. X is equal to negative 1. I mean negative 4. Double check that. Yep. So now we write our chart. So this is our interval. This is our number. This is our sign. So now we are going to do negative infinity to negative 4. And then we are going to do negative 4 to infinity. It's a terrible looking infinity. I am so sorry. And then, oh, my thing's glitching out. Okay. Then from here, we are going to do negative 5 and we're going to do 0. So then from here, we plug it in. That would become a 5, it would be a positive. This would become a negative. So this goes from positive. So then it would be a relative max. So now we have our relative max at x is equal to negative 4. We have increasing at negative infinity to negative 4. And we are decreasing at negative 4 to infinity. I really need to practice my infinities. Last problem. 15 negative x squared over 2 minus 3x plus 3 over 2 y prime. That would be negative x. That would be negative 3. You solve for x. That would be x is equal to negative 3. So that means you would go like this. I didn't even check the answer. 14. We were right. So we would write interval, we would write number, we would write sign. As you can tell, trying to do this quickly as possible. Negative infinity to negative 3 interval. And don't forget your parentheses. Negative 3 to infinity. And then we would write, this is supposed to be number. And this we would write negative 4 and 0. So we plug in negative 4 and that would become a positive. We do this negative, so it would go from increasing positive. So then it would be a relative max. So we have a relative max at x is equal to negative 3. It's increasing from negative infinity to negative 3. And then we have our decreasing interval from negative 3 to infinity. And that is it for just finding the relative mix and max and min, not mix, on open intervals where the function is increasing and decreasing. In the next video, I will go over how to find the full points, find all points of absolute minima, and maxima on a given interval. My name is Jesus Peralta, and I hope you have a good night.